Hey there. This is a real standard fare for stats and econ and business. And I had to actually have this memorized for both my econ degrees and my stat degrees. So, in case you're going on to grad school, make sure you know this well. So, we're going to start out with a theoretical model. Y is equal to beta 0 plus beta 1 times x plus epsilon. And that's making the assumption that you have perfect knowledge. All right, guess what? Well, we don't. So, what we need to do is make some assumptions, and we're going to find some sample estimates for our coefficients, our beta 0 and our beta 1. So, this is the overall model. Let's look at the model for a particular observation. So you have y sub I is equal to beta 0 plus beta 1 xi plus epsilon I. And the residuals for that, the residuals are just the model minus, or excuse me, the actual minus the model. That's going to be the y, which is the actual, minus the beta 0 minus beta 1 x sub I. So our goal is to minimize the error sum of squares, and we write that, we square both sides, and then take the summation. And this is also saying, yes, there are n observations. I didn't want to put the limits of summation, takes too long. Okay, so to minimize, this is from our old calculus days, we take the partial derivatives first with respect to beta 0 and then with respect to beta 1. We'll set those equal to 0 and solve for the respective coefficients. So when I take my partial with respect to beta 0, I take 2 times, I bring the 2 down in front, and I have the summation of yi minus beta 0 minus beta 1 x1 times, then you take the derivative of the inside with respect to beta 0, and that's going to be minus 1. So I'm going to take that, I just multiplied the 2 times the minus 1, and that gave me minus 2, and that times the summation of yi minus beta 0 minus beta 1 xi is equal to 0. Okay? Well, what I can do, since I've got 0 on the right-hand side, I'm going to divide both sides through by minus 2. So right-hand side still stays at 0, and I just lose that leading constant at the beginning. So what I'm going to do is push the summation sign through on each piece. So I'll have the summation of the y's minus the summation of the beta zeros minus the summation of the beta 1 times xi equal to 0. So the summation of the yi stay the same. The beta 0, since there's no I on there, we can think of that as just being a summation of beta zeros of n of them. So we get n beta 0. In the next term, since there are no i's on the beta 1, I can push that on the outside of the summation. So that leaves me with beta 1 times the summation of xi. So my goal, as I mentioned, is to solve, in this particular case, for beta 0. And I add n beta 0 to each side. And then I want to have beta 0 equals to something. So I just divide through by n. I have the summation of yi over n minus beta 1 times the summation of xi over n. And you typically see this as y bar minus beta 1 times x bar equal to beta 0. And that's what you see in expression 3.4 on page 62. Okay, so we solve for our beta 0. Now we have to solve for the beta 1. So we're going to attack this the same way. I pull the 2 down in the front. Now this time, I'm taking the derivative with respect to the beta 0, or my fault, beta 1, and I've got the minus xi term there. Okay, so let me scoot down. Oh, sorry. I have minus 2xi times the summation of the quantity yi minus beta 0 minus beta 1 x sub I equals 0. Here again, I'll divide through by the minus 2. And I have xi, excuse me, xi on the outside times the summation of that same quantity equal to 0. Now I'm going to go ahead and push the xi through. So I'll have the summation of xi yi minus beta 0 xi minus beta 1, it's xi times xi, so that'll be xi squared equal to 0. Okay. So now what I have to do, you got to plug back in, you take your expression for beta 0 that you had in the previous part, and you plug that in here and solve for beta 1. So I've got the summation of the xi yi, excuse me, the summation of the quantity xi yi minus, and then this term in the square brackets is my estimate for beta 0 times x sub I minus beta 1 xi squared equal to 0. So then what I'm going to do is take the term in the brackets and multiply that by the xi. So I have the xi yi stays the same. I have minus xi times summation of yi over n. Now I've got minus a minus, so that goes to plus. So I have plus beta 1 xi times summation of xi over n minus beta 1 xi squared. Okay, now let's operate with the summation, and I have summation of xi yi minus summation of the xi summation times summation of the yi over n plus summation of the xi times summation of the xi. We'll take care of that in the next step over n. And then minus beta 1 summation of the xi squared. Okay, so in this one I'm solving for beta 1. So I've got summation of the xi yi minus summation of the xi times summation of the yi over n. I push all the terms that have the beta 1s on the right hand side. So I have beta 1 times summation of xi squared. I added that to both sides. And then I subtracted the term beta 1, and this term, the summation of the xi times the summation of the xi, is summation of the xi, the quantity squared, over n. Okay, and as I move to the next step, the left-hand side stays the same. The right-hand side, I just factored out my beta 1 from both terms. And then I solve for beta 1. So all I did is divide both sides through by this term. And there we have it. Okay? Hope you enjoyed that, and I'll get some of the rest of the stuff very soon. Thanks. Bye.